Hi everybody, tonight's video is going to be about polygons, and we're going to start with just a general definition, give you some examples of what are polygons and what aren't, and then we'll talk about some different classifications for polygons. In the next video we'll talk about finding area and perimeter of different polygons. So let's just get started with basic definition. Polygons are closed shapes made up of coplanar segments whose sides have common endpoints, and each side only intersects another side at its endpoints. So a few important things to remember here. Polygons are closed shapes. The sides are all segments made up of coplanar segments, and they have common endpoints, and they only intersect at their other endpoints. Okay? So we have some examples of polygons and not polygons here. So some of these are going to be very familiar shapes to us. And if you look at all of these over here, they're all closed, which basically means every side is connected to another side. And the other important part of that is they are only connected at their endpoints. So if you look at all the endpoints here, they are all connected. There's no like overlap or anything like that. Everything is closed. Over here are some examples of not polygons. All right, this is not a polygon because it's not closed, right? So we have this little gap here, so the sides aren't connected. The segments are not ending at another segment's endpoint. So that is not closed. Here, this shape has curves. So this one is not a polygon because it's not made up of segments, of line segments, okay? So here we would have no segments. Well, there's a couple segments, but we could say not segments then. So not segments for sides. And here, the problem with this shape, the reason it's not a polygon, is because its sides do not intersect only at endpoints. So this last part of the definition, the sides can only intersect each other at endpoints. Here they intersect in the middle, right at this point here, which is not an endpoint, right? So they kind of cross over there. So here are polygons, here are not polygons. So just a few examples of ones that are not. Now, when we're talking about naming these different polygons, a specific polygon will be identified using all of the points of the vertices. So for example, I would call this triangle ABC, right? I would refer to it using the points of the vertices, right? A, B, and C. Right here, I have a pentagon, and I could call this D, E, F, G, H. So I refer to this polygon using all of the letters, right? So this is pentagon, DEFGH, or polygon DEFGH, and so on and so forth. So for however many sides I have, that's how many vertices I'll have, and so that's how many letters I'll have to use when naming this polygon in a sentence. The other way that we name polygons is we have a general type or general classification that identifies the polygon by the number of sides it has. So we are already used to certain shapes. So a three-sided polygon is called a triangle. And a five-sided polygon like this is called a pentagon. And there's different names for the different number of sides of polygons that we have. So for example, this is a seven-sided polygon, and that's called a heptagon. And this is a 10-sided polygon, and so that's called a decagon. There's a table in your book if you'd like to look at the different names for other polygons of different sizes, of different numbers of sides. But in general, we'll probably usually get used to just referring to these polygons using the letters that are at the vertices of all of the sides. Okay. So now there's a few different ways we can classify polygons. We can classify them as concave or convex. And concave polygons, there's a few different ways that these can look. So concave polygons look something like this, where there is a side that kind of like points in. The way that I generally think to distinguish between convex and concave is I just look at all of the sides and all of the, let's get back to the normal pen, all of the vertices. And I kind of put an arrow there. And I think of each one of these corners as an arrow pointing somewhere. And if I have any arrows on the inside of the polygon, then that means the polygon is going to be concave. So kind of, if you think of like concave as if it's like caving in on itself. So right here, I have an arrow that is on the inside of the polygon. So that's how I know it's concave. If I look over at this convex polygon, all of the arrows that I'm going to put on the vertices here are all pointing out. They're all pointing away from the polygon. So that would make it convex. Another way that you could think of this is if you draw along the sides. So sometimes I think of just the way that the vertices, where the angles are all pointing out. Another way that you could think of this is if you extended the sides of the polygon in each direction. If they ever cross through the polygon, through the inside, then it would be concave. If they don't ever, it'll be convex. So here, if I extend all these lines of the sides of the polygon, it never crosses through the interior here, so I know that this is a convex polygon. Over here, if I were to do the same thing, I extend all of these lines. So far, so good. This is okay. This side's okay. But once I get to this side, I extend it, and it goes right through the inside of the polygon. So that's how I know this one is concave. So you can do it either two ways. You can do it by the sides, by extending all the sides, and if you see anything that cuts into the middle of the polygon, you'll know that it's concave. And you can also just highlight the edges or the vertices and see where the arrow is pointing. If it's always pointing out, it's convex. If there's any that are pointing in to the inside of the polygon, it's concave. Okay, so those are two things. I can always ask if a polygon is concave or convex, and you should be able to tell. And polygons are all kinds of different shapes, so you'll notice that this is a 1, 2, 3, 4, 5, 6-sided polygon, but it doesn't look like a nice hexagon that we're used to. Those shapes that we're probably more familiar with are what are called regular polygons. So if I use the shape tool here and I make any sort of polygon, it's always gonna make a regular polygon. And a regular polygon is one where all of the sides are congruent. So if you see something that's a diagram and you see that every side has the hash mark on it, right? That's identifying that all of these are congruent. Remember, that's our symbol for congruence. And the angles are also all congruent. So the nice thing about this tool for drawing these polygons, it always makes a regular polygon for you. But we can have polygons of any shape and size. So like I just drew on the other side, so that's also a 6-sided polygon, but it's not a regular one because these angles are different, right? This angle's on the inside. Oh, I used the wrong pen. So this angle is on the inside, right? And this is obviously going to be much different than this angle here. And these sides here are much longer than this side here. So this is irregular. This is what we would call regular. It's still fine, still a polygon, just looks a little bit different, okay? So those are the different classifications. So our polygons can be convex or concave, and they can be regular or irregular. So bring your notes with you to class tomorrow. We'll do some examples, we'll do some practice problems, and then we'll also talk about area and perimeter, which is something that we're probably already a little bit familiar with. So hope you have a great night, and I'll see you in class tomorrow.